All right, in trig substitution, we're going to have three choices. We're going to have a square root or a parenthesis to the 3/2 power or something like that, where we have a number minus an x squared, or an x squared minus a number, or an x squared plus a number. Now, when I'm talking about by number, so look back up here, if I have a 9 there, then remember A is 3. If I have a 4 there, A is 2. If I have a 25, A is 5. In other words, when I start using this over in work, the A is the square root of whatever this number is. All right, now here's the rule. If you have minus x squared, if the x squared is minus, then you're going to substitute the sign of theta. So we're going to put in here, let x be equal to 2, or a sine of theta. So if it's minus x squared, we're going to let x be equal to the square root of that number, sine. If the x squared is then positive and you're subtracting a number, then we're going to let x be equal to a secant theta. Trig substitution, which means we're going to let trig words now replace the x's. If it's plus, then we're going to let x be equal to plus a tangent theta. So there's your decision to start with. If it's plus, it's tangent. If it's x squared minus, it's secant. If it's minus x squared, it's sine. And whatever this number is going to be, the square root of that's going to be in front. Whatever this number is, the square root of that's going to be in front. Okay, so that's in your notes, and you can refer back to it. But that's the rule. Minus x squared, replace with sine. X squared minus, replace with secant. And plus, if everything's positive, replace with tangent. So now let's look at example 1 in the notes. Example 1 says we want the integration of dx over the square root of 4 plus x squared. And we can't use the power rule, we can't use inverse functions, and we can't use anything else. Then we want to look for trig substitution. So what we say then, if it's plus, we replace with tangent. And if this is a 4, we replace with the square root of that here. So we write x is equal to 2 tangent theta. Now, listen closely. We now take the derivative of this. So the derivative of x is dx, and the derivative of tangent is secant squared times the derivative of the angle, which is d theta. And now we substitute. Okay? So we're going to place this in place of the dx. We're going to place this in place of the x. So doing that, placing this for the dx, placing the 2 tangent for the x, squaring that, we get 4 tangent squared. Realizing I still have an integration sign here. I'm just saying, show the algebra from this step over here. All right, now what we do is we factor out 4 out of this. So we have 1 plus tangent squared. So we're going to factor 4 out of that. And we have this next line here. And by our trig identity, 1 plus tangent squared, it goes to secant squared. That's why we pick tangent for positive. So we have 1 plus tangent squared is equal to secant squared. Now we take the square root of everything on the bottom. So the square root of 4 is 2, and the square root of secant squared is secant. The square root of x squared is x. And look how simple it is from there. From there then, this divides into that, 2's drop out, and we have the integration of secant. And you need to memorize that as often as you're going to encounter it especially in trig substitution, the integration of secant is the log of secant plus tangent. And then don't forget your plus c. All right, so if it's plus, you replace it with tangent, and that's going to end up giving you secant when you get through. When you replace with tangent, you're going to end up getting secant. Whatever that area you replace it with is going to come down to be a secant. And then this part from here on is sometimes the hard part, because this one's easy, but sometimes when you get now back to a bunch of trig functions, you have to use power rules or log rules or whatever. And so it comes back down to some of the previous work that you've done. All right, now, wait a minute. This is in thetas. Our problem started at x's. So the second big thing about this then is to change it to x's. So let's look at how we do that. So I've rewritten the answer in terms of thetas. You now return to the substitution. We have x is equal to 2 tangent theta. We draw a triangle where this angle right here is the theta. And we go solve for that. So we move the 2 across, and tangent is side opposite over side adjacent. In other words, we don't have these written in there. You go draw the triangle, and you say, okay, the tangent of this angle is the side opposite over the side adjacent. And so the hypotenuse then is this side squared plus this side squared. And if you don't get what you had to start with in the original problem, if one of these sides is not what you had in the original problem, then there's a mistake. Some mistake either here or in your substitution or whatever. All right, so you go back to the original substitution, solve for the trig function, and then plug those in on the sides of the triangle. Now we answer the question, what is the secant of that angle? What is the secant of that angle? The secant of that angle is the hypotenuse over the adjacent. And there's the answer. So the secant is changed to the hypotenuse over adjacent, and the tangent is the side opposite over the side adjacent. So we must return to the triangle to change from thetas back to x's. And so this is your answer, and this is the final answer. What I'd like for you to be aware of, though, a lot of times in answers in the back of the book, you will see it this way. And what they do, it doesn't mean that you have to do that, but what they do is they go combine these into a common denominator, and then what's the log of all this numerator divided by number? Log is this minus the log of 2. Then they just take that log of 2 and stick it in this constant over here. So this answer is just as good as the answer you might see like this. So if you have a constant in the denominator on something like this, sometimes they won't write it down. They'll see that. All right, so let's go to example 2. Example 2 is where we have minus x squared. Minus x squared. So, our rule is if it's minus, we use sign. And then the square root of the number is what we place here. So then we take the derivative, so derivative x and dx, derivative sine is cosine, and derivative angle is d theta. Now substitute. So we'll go over here and place the 3 sine where the x is. So we have 9 sine squared. We replace the 3 cosine where the dx is. So we have that. And now we simplify. Well, factor out 9 here. And that leaves us there. Now, what is 1 minus sine squared? Well, it's cosine squared. So whenever you plug in sine as your substitution, it's going to come out to be cosine. And that's the reason we make these substitutions, is so that we can get rid of the square root sign. We make a trig substitution such that we no longer have a summation or a subtraction. We don't have adding and subtracting. Because you can't take the square root of 9 minus the square root of this. You have to have a single object in there to square it. So it comes out to be that times the dx. Don't forget the dx. A lot of times mistakes, sometimes we forget to put the dx in there. And now when you multiply that together, you get the 9 cosine squared. Now this goes back to previous knowledge on how do you integrate sine and cosine to even power. The integration of cosine to even power is 1/2 plus 1/2 cosine of double the angle. Well, that's great. And now we'll integrate that. So let's look down at the integration. So the integration of 1/2 x is 1/2 is 1/2 x. So this is d theta. So the integration of 1/2 is 1/2 theta. And the integration of cosine of 2 theta is, we had to put another 1/2. The integration of the cosine of 2 theta means we have to have a 2 inside and a 1/2 out front, so it's 2 of those 1/2s. Okay, now at this point, here's a new concept, and that is we must change it back to single thetas. If we have a 2 theta or 3 theta or 4 theta up there, then we have to use trig identities to get that to be thetas before we can change it back to x's. So the sine of 2 theta by trig identity is 2 sine cosine. Now, watch what I did. I factored a 1/2 out of here and took it out there. So that's what I did here. I factored a 1/2 out. So that leaves me theta. Leaves me 1/2 here. And then when I switch this to 2 sine theta cosine theta, those drop out. And so now I have kind of reduced to thetas. So what we do now is go to the triangle. So we go to the triangle theta. And you remember our substitution was x equals to 3 sine of theta. So dividing that by 3, that says that the sine of theta is side opposite over hypotenuse. Side opposite over hypotenuse. Well, then if you solve for this side, it's the square root of the hypotenuse squared minus that squared. And sure enough, that's what we had to start with. So we're probably doing this thing okay. Alright, so now let's look up here. We have the sine. The sine is side opposite of hypotenuse, so there's that replacement. Cosine is the side adjacent over the hypotenuse, so there's that replacement. Okay, now here's the one that sometimes students have a little difficulty understanding. Here's your substitution. So then you're just going to say, move this across and say the inverse sine of that. That's a mechanical way just to get it done. Here's what we're saying. This says that the sine of theta is equal to x over 3. This says what angle is the sine of x over 3. So anytime you have a theta down here, not a trig word with it, just a theta in the problem, then you go back to your substitution and go solve for theta. All right, let's now look at example 3. Now in example 3, we have x squared minus x squared minus. So x squared minus means that we're supposed to replace with secant. Again, this number is whatever the square root of that number is. So I'll replace x with secant. I have to take the derivative. So the derivative is secant tangent. Now we'll go substitute. For the x, we replace the secant. With the dx, we replace all this. So we're replacing all this for the dx. And we're replacing this for the x. And then we come down here and replace the x here. Factor out the 4. And we have secant squared minus 1. Now secant squared minus 1 is equal to tangent squared. So now we go over there and simplify, all right? So the bottom comes out to be 2 tangent. And the top, multiplied all together, is 4 secant squared tangent. And so tangents drop out. 2 divides into 4 2 times. And so we have the integration of 2 secant squared d theta. And the integration of secant squared is tangent. Now we'll go to our triangle. So our triangle is the secant of this angle is the hypotenuse over adjacent. And so the other side is the square root of the hypotenuse squared minus the side squared. So what is the tangent? What is the tangent of this angle? Well, it's the side opposite over the side adjacent. There it is. And of course, for your final answer in homework and stuff like that, you should divide that out. Okay, let's now look at example 4. All right, example 4, now we're taking up the next and kind of the last thing to look at. And that is limits. What do you do with trig substitution if you have limits in the problem? Okay, so here we go. It's plus x squared, therefore we do tangent. So we've done this before, so we do tangent. Derivative tangent is secant squared. Derivative equals 3 theta. Now we'll go substitute. Where the x squared is, we put this in and square it. Where the x squared is, we square that, so that's 4 tangent squared. Where the dx is, we put 2 secant squared d theta. And then where the x is down here, we square it, factor out the 4, 1 plus tangent squared. So 1 plus tangent squared is secant squared. Square root of that is secant. Square root of the 4 is 2. So we have to simplify. Now this will divide into this and give us 4. This will divide out and leave us one of these secants. So we now have tangent squared secant. So we look for ways of integrating that. There's not even a power rule or anything like that, so we must change tangent squared to secant squared minus 1. And it may not show it in the notes, but let's go ahead and take it forward and factor out the front, get rid of it. So, all right, so we have replacing tangent squared with secant squared minus 1. Now, what is secant times secant squared? And what's secant times 1? So we distribute that in there. Secant times secant squared, secant times 1. So what we have now is the 4 factored out in front, and secant cubed minus secant. Right? So what we do then is, and I'm going to kind of erase that and say, okay, we have secant cubed minus secant, so it's the idea of the integration of this and the integration of this. So the integration of secant cubed by memory or integration of parts, whatever way you learn to get there, or looking at the tables and reading it, is 1/2 secant tangent plus 1/2 log of secant plus tangent. And then the secant is the log of secant plus tangent. So the Integration secant cubed is that. By parts are memorization. And the integration of secant is the log of secant plus tangent. Okay, now simplifying this. 4 times this 1/2 gives us 2 of these, so we have 2 of those. And 4 times this 1/2 gives us plus 2 of these and a minus 4 of those. So we have a plus 2 of these and a minus 4, which gives us a minus 2 of the log of secant plus tangent. Alright, now let's continue over here, and I'm going to come back to that in a minute. So let's go over here now and look at what we do. Alright, we have limits now. So we have limits from 0 to 2. So we're going to do our triangle. So we go back into our substitution. Tangent is side opposite over side adjacent. And therefore, there's our triangle. And so we replace secant. Secant becomes hypotenuse over adjacent. Secant. Tangent becomes side opposite over adjacent. And then, so we have minus 2 log of the secant and the tangent. Okay, now we substitute it. Now we have it back to x's. These numbers are x's, not theta. So we can't use the 2 and the 0 until we get it back to x's. So now we put the 2 in there. Well, let's see, this would divide out, and that would divide out. And we put the 2 in there, that's the square root of 8. That's 2 times the square root of 2. And then x is 2 over 2. And so what happens is, this ends up being 2 times the square root of 2. Okay, minus 2 times the log of. Okay. Now this would end up being 2 times the square root of 2 over 2 plus 2 over 2. So we end up with the square root of 2 plus 1. Alright, now that's changing it back to x's. Now let's don't forget that we've got to go put the 0 in there. So we're not going to put the 0 in it. Well, that's 0. Put the 0 here times that is 0. So that's going to be 0. And put the 0 here, and what we have is 0 here, and we have 1. We have the square root of 4, which is 2, over 2 is 1. And the log of 1 is 0. So we don't have to worry about that. Okay, so that's how you do if you have limits. Go get it changed to x's, just like we've been doing all the other examples, and then plug in the limits. Now let's go back to the previous one and show what I have written here. In other words, if you wish, I don't think it's any easier or whatever you want to do, if you wish, you can change your limits. If you have thetas, you have to change your limits. Well, to change your limits, you go back to the substitution equation and put, so now you go put the limits. If I go put a 2 there, the upper limit, then I get the tangent is equal to 1. What angle is a tangent equal to 1? Power 4. Then you go put your lower limit there. What angle is a tangent? 0. 0. So the way to change your limits is to go take your x limit, put it in your substitution equation, and figure out what the angle is. Then put your angle there. Put your lower limit where the x is, figure out your angle, put your lower limit on there. Now, let's see how that works out. Okay? 45 degrees. The secant of 45 degrees is the square root of 2. The tangent of 45 degrees is 1. Same answer we had a moment ago. And so I come over here, I have the log of secant of 45 is square root of 2. Tangent's 1. If I go plug a 0 in there, the tangent is 0, 0, wipes that out. The secant of 0 is 1. Tangent of 0 is 0. So that's the log, get the same answer. So it's your preference of whether you want to change it, the angles, or whether you want to go back and change it into x's and then plug in your original limits. Alright, so this is an example of dealing with limits. Now let's look at the next example, example 5. And the example 5 is picked to be able to handle 3/2 power. Okay. Again, it's the 4 plus x squared. It's all the same substitution. The point is, how do you deal with 3/2 power? Several problems in textbooks have the 3/2 power, either the numerator or the denominator. So here we go. We let x be equal to 2 tangent theta, and go substitute. So we go substitute this, and we get 4 tangent squared, 4 plus. Take the derivative of that, that's replaces with dx. And that. Now, the algebra here. All right, first of all, we factor out the 4, and so we have 1 plus tangent squared. So 1 plus tangent squared, secant squared. Now, here's what you need to know. When you have a fractional power of something, you take this root of it, and then you raise that answer to that power. For instance, what is the square root of 4? It's 2. What is 2 cubed? It's 8. What is the square root of the secant squared? Well, it's secant. And then you take that and cube it. So if you have a fractional power, you're going to take the square root of this number and then raise that answer to that power. And then you're going to simply take this word and raise it to that power. Okay, so that's this example. Fractional powers like that. And now when you multiply it together, you have 16 secant to the 5th. Okay, so let's look at how we finish that up. So, we have a big old long list now, don't we? So what we do then is this. Secant to the 5th power can be done by parts. And you get all this. Okay, by parts it'll come back down to secant cubed, and then that kind of finishes out the secant cubed. You can look in the back of your calculus book at the tables that has secant to the n power and follow this reduction formula process. So whichever way the teacher wants you to find the secant to the 5th power, do so. But here it is. There is the integration of secant to the 5th power. So we simplify. 16 times this, 4 divides. 16 times this divides. 16 times this. Okay, this should be a 6 right there. All right. Now, we go back to our triangle. We go back to our triangle. So we draw our triangle, and it's x over 2. So now we go at secant cubed. Well, what's secant? Secant is the square root of x squared plus 4 over 2. And we just put all that in parentheses, cubed. Then the tangent is side opposite over side adjacent. And then 6 times secant is the square root of the x squared plus 4 over 2. And the tangent is the x over 2. And then you put these same things here. So you have the square root of x squared plus 4 over 2 and x over 2. And don't forget, you always have a plus c on indefinite intervals if we don't have limits. All right, now, while the camera's on that, just listen. I'm going to work one more example that's not in the notes, but I'm not going to work the example 6, 7, 8 in the notes. You can follow through those. I think they'll be clear after I work this next example. So, if you wish, why don't you write this next example on the back of one of the pages in the notes. All right, I'm going to go real slow in this one so you can kind of, if you wish, to copy it down if you want to the notes or watch it. But, all right, what we're going to do is take like example 4, same problem example 4 basically, and what happens if I have numbers in here with the x? What happens if I have numbers in here with the x? So, what you do is you let the square root of this be equal to x. So the square root of this is equal to that, equals whatever the square root of that number is, and if it's plus, it's tangent. And that's all there is to it. The new concept. And it requires a lot of fractions in the work, but that's all there is. If you have a number there, that this thing that you're going to equal on the left side be equal to the square root of that. So, when I take rid of this, it's 5 dx. And taking rid of this just like before. Now go solve and move the 5 over here. And now you have what dx is replaced with. And you have what x is replaced with. So, what you need to do here then is move the 5 over also. So, for in place of x, you're going to put 3 over 5 tangent theta. So you square that, you get this. In place of dx, you have this. Now, what's the algebra for the denominator? If I go in here and put this squared, I get a 9 over 25, and the 25s drop out, and so you get the 9. So if you have this fraction, and you put that denominator, that when it's squared, divides that out, now it works. Now we do what we've been doing, factor the 9 out, square root of 9 is 3, 1 plus tangent squared, in other words, we factor the 9 out, and this is secant squared, square root of the secant squared is secant, square root of 9 is 3. Simplification now, 3 we're going to 27 9 times. Go take that, move it out front. And we're now back to example 4, tangent squared secant, replace, multiply, come over here, then look. And what we have is secant cubed minus secant, integration of that, all exact same work. So it becomes the same thing. All right, let's look now to change it back to x's, kind of make sure that you see the values for x. Now, remember now, our substitution was 5x equals 3 tangent. So, this says the tangent is the side opposite over side adjacent. So that's 5x, so that's 3. And so the hypotenuse is this side squared plus, and sure enough, that's what we had to start with, so we've done it correctly. And now you substitute. Replace secant with hypotenuse over adjacent. There it is. Tangent, side opposite over adjacent. There it is. And then so on down. And now when you plug in 0 and 3 over 5, if you go put 3 over 5 here, okay, you get 9 plus 9 is 3 times the square root of 2. 3's drop out, square root of 2. Put a 3 over 5 here for x, that's 3. 3 over 3 is 1. So, all right, so that concludes the, I think, enough examples to be looked at for trig substitution. There are 3 other examples in the notes that you should be able to follow in case you run across one looking like those.